So today we are going to be looking at Leetcode 139 word break, which was a question for a Google interview, and it's a relatively hard problem to solve. Okay, so let's dive into it. We have been given a string s and a dictionary of string word dictionary. We have to return true if s can be segmented into a space separated sequence of one or more dictionary words. We can use the same word in the dictionary multiple times for our segmentation. Okay, first of all, let's try to understand what this problem dictates, and going to the drawing board would be handy in our case. So let's just understand with the help of examples. So you are given a string s, and no matter in how you slice it, how you segment it, or how you generate substrings from it, you have to make sure those generated substrings are contained at least once in your word dictionary. So for the first example that I'm going to be showing you guys is for example 2, apple pen apple, where your word dictionary contains apple and pen. So if you segment it out with apple being the first substring, pen being the second, and the remaining apple being the third substring, you see that apple and pen are contained in the dictionary, and you can use this apple string multiple times in your segmentation. Hence, our code for this case would return true. Now, interesting case happens for the third example with the cats and dog. So when we segment it out, the first substring could be cats, and then you move on to and then you move on to the remaining OG. You see that cats and are contained within the word dictionary, but OG is not. You can also say I would not segment it out in that way. I'll try a different segment where I put cat as the first string, then I do sand as the next substring, and I do the remaining OG as the last substring. But you know but even in that case, you are also falling back to the same place that you have cat and sand in the dictionary, but you don't have OG. So no matter how you split it, you can't get all the substrings in the dictionary. At least one or two will be left out, and hence for this case the code should return false. Now that we understand the problem, it makes sense for us now to actually try to analyze how we can go about solving this problem. With any problem, we can think about the brute force way. So we can just stop at every single index and generate all possible substrings from that index. For example, from A we can do A, we can do AP, we can do APP. From P we can do PP, we can do PPL, PPLE, and you do get the point. So generating all these substrings and checking whether those substrings are present in the dictionary would be a very time consuming thing to do, first of all, and secondly it would be very hard to track, and also it would be harder for us to design an exit case, like when do we know that we have traversed all possible substrings, and how do we decide that all possible substrings in all possible ways are contained within the dictionary or not. So the brute force solution is messy, to say the least. So an effective way to solve it would be using dynamic programming. And if you guys remember, dynamic programming reuses the solutions to the smaller subproblems to solve the original big problem in question. How do we use dynamic programming for our problem cases, or to solve this Leetcode problem? You guys would be familiar with using the dynamic programming arrays. So if I recall, this dynamic programming arrays has these indices. these indices would store the smaller subproblem solutions so that we can use those smaller subproblem solutions to solve our original dynamic programming solutions, and we don't have to recompute a lot of the computation tasks. So we'll see how that comes into action. Let's just also look at another useful aspect that we'll be trying to solve this problem, which we are calling as max length of the dictionary. Let's just write the dictionary. So why do we need it? um, why do we need the maximum length of the dictionary? So this is basically needed so that it makes our computations just a little bit less time consuming. Why? Because we are essentially checking that whether these substrings are present in the dictionary. So why not just use the maximum length of the dictionary to our benefit? Because if you just think about it, no matter how we slice it and generate substrings from the original string, we can at most find any substring which is of equal length to the length of the maximum string in the word dictionary, right? For example, from apple pen apple, we can generate maximum length substring of 5, because that is what the maximum length of the strings that are present in the word dictionary, which is 5. For cats and dog, we can only do 4 because cats and these are of length 4, which is the maximum length of the all the strings that are present within the word dictionary. Same for Leetcode, we can do 4 because Leet and code are of length 4. All right, so the main aspects of the dynamic programming solution to this problem I have been explained. Now we see how our whole dynamic programming can be solved with this drawing board. So the dynamic programming array for apple pen apple, there would be 13 indices and one more index to store the final result. We kind of initialize the first index to be true because that's where we are starting out our exploration, and the empty string is segmentable using no words, so we have to make it true as our base case. Okay, so moving forward, so let's just try out with the maximum length approach, right? So for apple pen apple, for any string, we'll just say all these are false, all the other indices are false, and we'll make them true by our process of traversing the string. So maximum length is, we start with a and we see that when we maybe reach apple, that's when we have to make this as the true, that index as true. So hence we'll have this as false, this as false. So APPL, and when we reach E, that is when we have to say this is true. So that is done for apple. Now, how dynamic programming benefits you? How is it better than brute force? If you remember, I talked about generating all possible substrings from a given string for our brute force solution. When we have done this for till index 5, we don't have to check the substring combinations generating from P, generating from the second P, or generating from L or E, right? Because all these are false. So we don't have to check for P, we don't have to check for PP, we don't have to check for PPL, we don't have to check for PPLE. We don't also have to check from P and then PL and then PLE. So you do get the point that with dynamic programming approach, we are essentially carving out a lot of checks for a lot of substrings. So that is where dynamic programming sort of proves its due diligence over our traditional brute force approach. Moving on, so next we are we still have how many indices to go? 1 2 3 4 5 6 7 8. So we can easily um, accumulate other strings, and if we can also accumulate the maximum length substring here, um, maximum length string as a substring for our dynamic programming array. So moving on, so we start checking with the combination for pen. So these would be false, of course, all these would remain false. So for P it would remain false because P is not contained in the dictionary. For PE again it would be false, but for PEN then we have to make it true. Again, if we go back to the usefulness of the dynamic programming approach, when we make this index as true for PEN, then we don't have to check for E, right? For all those indices, all those substring combinations from the letter E. So we make these this index ending at n being true, hence we don't have to check the previous index and all other substrings combinations generating from them. Again, moving on to APPLE, so all these would be false. APPL and this E would be true, and because apple is contained within the dictionary, again these combinations with P, PL, all those are don't have to be checked. So you see, we have reduced generating a lot of substrings with the dynamic programming approach, and we'd be returning the value of the dynamic programming array at the last index of the dynamic programming array. So the whatever be the last index of the dynamic programming array, we have to just return it. So if it is true, then we return it true, and if it is not true, false, then we return false. Alright, so now that we have seen why it works for this case apple pen apple, let's do the more interesting problem cats and OG. So how does this happen? Okay, so, the first index we initialize it to be true and keep all the other indices as false. So F. Not writing all the F's because it's kind of hard. The drawing in Canva is something else. Okay, so again, let's just try it with the maximal length approach of the word dictionary. So cats, so CATS, so this would be false, and when we reach S we have to make it true. Now with the dynamic programming approach, we don't have to check all the substrings generated from A, T and S. Okay, so moving on, we can go to A and D, right? So this is false, this is false, this would be true, and we don't have to check with N or D. Finally, we can do this OG, so this would be false, this would be false, because OG is not contained in the dictionary. Hence, the final indices would be returned as false. I don't know why I drew so many indices, because that's on me. I might have just miscalculated that. So you see for cats and dog, we would be returning false. And you can check with other combinations like cats and OG. I think you'll reach that it will always generate false for as an example. Okay, so when we sort of understand the problem and intuition on how to solve it, we using dynamic programming and maximum length of the substrings, maximum length of the strings in the word dictionary. Let's just go ahead and try to solve the programming approach. So let's first of all find out this max length. That would be our max of all the lengths for the strings that are contained within the word dictionary. Okay, now we initialize the dynamic programming array. So all the indices would first of all be false, and we have to do it till n+1 times because the first index is our base case where we have to make it true. Now our first loop would be the I loop, and that should run till n+1 because we have originally said we have originally dictated the dynamic initialize the dynamic programming array till n+1. Now j would start from 0 or whichever is the difference of the current index with the maximum length of the strings in the word dictionary. So for j in our range of, let's just do a max with 0 and I minus max len, and we will run it till I. If our dynamic programming array at jth index is true and our string that is contained within I and j, so we can slice it, is present in our dictionary, so then we make the ith index as true, and we don't check the other combinations that we so heavily talked about. So then we break out of the jth loop. Finally, we should just return the dp contained at the last index. Let's just see, it should satisfy all of our test cases. Well, it does, and we have been beating up the time complexity should be O of n squared because we are using a nested loop, and the space complexity should be O of n because we are using an in-place dynamic programming array. Well, you can make it faster than 3 milliseconds, of course. So you see in the word dictionary we are not accounting for duplicate words. We can just use a set for it. So why not just use a set? So word set would be our word dictionary converted into a set. Then we use word set everywhere instead of word dictionary, and should be faster than 3 milliseconds. Yes, it is. So very efficient solution with dynamic programming, solves a lot of our problems in terms of checking for a lot of unnecessary substrings, and solves it in still O of n square complexity, but does the retrieval operation from the dictionary takes less time, so that's why it's faster than our previous approach. So thank you guys for spending 20 minutes on watching my explanation video. I have tried to analyze why dynamic programming suits this kind of problems better, and I would appreciate your constructive feedbacks on my videos as usual. Thank you, and I hope to catch you guys in the next one.